When gases are dissolved in water and you increase the temperature, their solubility decreases because they're quite volatile. They have kinetic energy and they have very weak bonds with the water, and so they're quite happy to pop off into the atmosphere, and so their solubility decreases with increasing kinetic energy. You can analyze each of the different types of gases. Some of them are dipole-dipole bonding, some of them hydrogen bonding, some of them dipole-induced dipole bonding. May not get a question related to that, but you could be. And so this one's quite interesting because it's to do with the whole negative positive feedbacks. One of the negative positive feedbacks with global warming, carbon dioxide can get absorbed or released from the ocean based solely on temperature. Now, for salts, in most cases, there is an increase in solubility with increasing temperature. Now, entropy is something we don't cover that well in this syllabus, which will describe some strange results of it not increasing with temperature. And so you can see that these lines here represent the most that you can put in 100 grams of water. So we take those 100 mils of water, and so that is all that you can put in there. If you can put slightly more in there, it's called supersaturated. You do that with a trick by absorbing too much and then cooling the solution, and you can at a particular point in temperature, you can actually have more salt in there than what this graph actually says. Otherwise than that, if it's below the amount of salt you've got in there is below the line, then it is an unsaturated solution. So going to a problem now. So if you have at 40 degrees, if you have 40 grams of potassium bromide and 50 mils of water, will it dissolve? So what you do here is you need to look to the graph and you need to find 40 degrees for potassium bromide. And so there's 40 degrees, there's potassium bromide. It's a coincidence it's on the line there, and so I can do a fairly easy reading of 75 grams of water. The most it can hold is at 40 degrees is 75 grams of potassium bromide is the most that 100 grams of water can hold at 40 degrees Celsius. So the ratio here, and this is different to how I've seen it done everywhere else, but it's basically just following through from what you already know of your stoichiometry. So there's a ratio, so 75 grams to 100 grams of water at 40 degrees Celsius. You could go either way now, and you could go with the 50 mils of water as a new ratio, or the 40 grams as a new ratio. I've gone for 50 grams of water as a new ratio, and so cross multiply, and so x equals 37. So for 50 grams of water, the most amount of potassium bromide you could hold is 37.5 grams. However, you have 40 grams, therefore you got too much, it's in excess. So we're just doing limiting reagents here, cross multiplying stoichiometry in some ways technique. So therefore the answer is it will not dissolve because you got too much.